Hello, 9th graders! This is the Teleradyo Eskwela, Tara na! Welcoming you to Mathematics Night. We are glad to be with you in this new normal journey of schooling through radio broadcast. I am your Teleradyo host, teacher Miss Pajan M. Campo from Tagum City National High School. And we would like to thank our radio partner, Hope Radio 107.1 DXHS, where we are airing our episodes for junior high school. Thank you for your generosity. Are you all excited to learn? That is great! Come and join us. Stay tuned and be one of a kind Math Talino student. Before we begin, I would like you to get your modules, your notebook, and your pen, and be comfortably seated in the comfort of your homes. Our topic for today will be simplifying expressions with rational exponents. This topic will be brought to us by our Teleradyo teacher, Teacher Rosella A. Deliva from Tagum City National High School.
Hello, dear students! Now that you are all settled in your homes, kindly bring out your pens and notebooks and secure your learning module, specifically your Mathematics 9, Quarter 2, Module 5. Here are our learning objectives for today. At the end of the lesson, you are expected to illustrate expressions with rational exponents, apply laws of exponents in simplifying expressions with rational exponents, and transform expressions with rational exponents into radical expressions and vice versa. To start this lesson, I will give some illustrations involving the laws of exponents. Tell me what rule is being applied to each item. Let us start. 4a is not equal to 0 and b is not equal to 0. Number 1. A raised to x, a raised to y equals a raised to x plus y. What rule is being applied to this? It is the product rule. Number 2. A raised to the power of x divided by a raised to the power of y equals a raised to the power of x minus y. Tell me what rule applies to the given. It is the quotient rule. Number 3. The quantity of a raised to x is raised to y equals a raised to xy. Is it a power rule? It is a power rule. Number 4. Thus, the quantity AB is raised to the power of x equals a raised to x, b raised to x. Illustrate the power of a product rule? It illustrates power of a product rule. How about number 5? The quantity a over b is raised to the power of x equals a raised to the power of x over b raised to the power of x. It represents what rule? Yes, that represents a power of a fraction rule. In addition, a raised to the power of 0 equals 1 illustrates a zero exponent rule. A raised to the power of negative x equals 1 over a raised to x illustrates a negative exponent rule. And a raised to the power of x over y equals the yth root of a raised to x shows a fractional exponent rule. Since we have recalled the rules or laws of exponents for integral exponents, we can apply these laws in simplifying expressions with rational exponents or fractional exponents. For example, simplify the expression x raised to the power of 1/2 multiplied to x raised to the power of 3/4. According to the product rule, when two numbers with the same base are multiplied, we will just copy the base and add the exponents. In the case of having rational exponents, we need to find the least common denominator, then add the numerators, just like adding regular fractions. Let us focus on the exponents 1/2 and 3/4. The least common denominator is 4. For the denominator 1/2, divide 4, which is the least common denominator, by the original denominator of 1/2, which is 2. So 4 divided by 2 is 2. Multiply the result, which is 2, by the original numerator of 1/2, which is 1. So 2 times 1 is 2. 2 is the numerator of the equivalent fraction. 4 is the denominator of the equivalent fraction. From 1/2, the rational exponent is now 2/4. So x raised to the power of 1/2 multiplied to x raised to the power of 3/4 is now x raised to the power of 2/4 multiplied to x raised to the power of 3/4. Apply the product rule, so that becomes x raised to the power of 2/4 plus 3/4, which is equal to x raised to the power of 5/4. Take note. Always check if the resulting exponent can be reduced to lowest term. 5/4 is already in its lowest term. Example number 2. Simplify the expression with rational exponents. 2v raised to the power of 2/3 multiplied to -5v raised to the power of 1/2. To simplify the given expression, multiply first the variables 2 and -5. Then apply the product rule in simplifying the variables with rational exponents. Thus, the expression is now 2 multiplied to -5 multiplied to v raised to 2/3 multiplied to v raised to 1/2. The rational exponents are 2/3 and 1/2. The least common denominator of 3 and 2 is 6. The rational exponents are 2/3 and 1/2. Find the least common denominators. The rational exponents are now 4/6 and 3/6. So, 2v raised to the power of 2/3 multiplied to -5v raised to the power of 1/2 is now -10 multiplied to v raised to the power of 4/6 multiplied to v raised to the power of 3/6. So that is equal to -10 v raised to the power of 4/6 plus 3/6. Hence, the simplified form is -10 v raised to the power of 7/6. Again, always check if the resulting exponent can be reduced to lowest term. 7/6 is already in its lowest term. Remember, if a and b are rational numbers and x and y are real numbers, then a raised to x, a raised to y equals a raised to x plus y. Example number 3. S raised to the power of 3/4 divided by s raised to the power of 1/2. According to the quotient rule, when two numbers have the same base, copy the base and subtract the exponents. This case has rational exponents. We need to find the least common denominator of the two rational exponents. So, s raised to the power of 3/4 divided by s raised to the power of 1/2 becomes s raised to the power of 3/4 minus 2/4, which is equal to s raised to the power of 1/4. Again, always check if the resulting exponent can be reduced to lowest term. 1/4 is already in its lowest term. Remember, if a and b are rational numbers and x and y are real numbers, then a raised to x over a raised to y equals a raised to x minus y. Let's have another example. Example number 4. 81a raised to the power of 1/2 divided by 27a raised to the power of 3/10. In simplifying this kind of expression, work on first with the numerical coefficients. Thus, divide 81 by 27. This case has also rational exponents. we need to find the common denominator of the two rational exponents. So 81a raised to the power of 1/2 divided by 27a raised to the power of 3/10 becomes 81 over 27 times a raised to the power of 1/2 minus 3/10. Simplify 81 over 27 and that is equal to 3. Find the common denominator of 1/2 and 3/10. The common denominator is 10. So it becomes 3 times a raised to the power of 5/10 minus 3/10, which is equal to 3a raised to 2/10. Take note, always check if the resulting exponent can be reduced to lowest term. Hence, the simplified form is 3a raised to the power of 1/5. At this point, let us define the basic parts of a radical expression. The basic parts of a radical expression are the radical symbol, radicand, and index. A radical symbol indicates the extraction of the root of the quantity that it follows. A radicand is a quantity inside the radical symbol, and the index indicates the roots of extraction. Given the expression, the cube root of the quantity 2x minus 4, what is its index? Absolutely right, 3 is the index. Can you identify the radicand? Correct! The quantity 2x minus 4 is the radicand. Take note, expressions with exponents are in exponential form, while expressions with radical signs are called radical expressions. This time, let us transform an exponential expression to a radical expression. Remember, we can change any expression with rational exponents into a radical expression by using the denominator of the exponent and using it as an index, and the numerator becomes the power of the entire radical expression. Example, transform x raised to the power of 1/3 into a radical expression. In this expression, x is the base, 1/3 is the exponent, 3 is the denominator of the exponent, 1 is the numerator of the exponent. Hence, 3 will become the index of the radical and 1 will become the power of the entire expression. In the case that 1 is the numerator, you don't need to write 1. So x raised to the power of 1/3 is equal to the cube root of x. Let us now proceed in transforming a radical expression into an exponential expression. Take note, we can change any radical expression to rational expressions just by using the index of the radical as the denominator, the power as the numerator of the rational exponent of the expression, and the radicand as the base of the exponential expression. For example, transform the fourth root of the quantity 5ab, which is raised to the power of 5. The root of the radical expression is 4. And the exponent is 5. And the base is the quantity 5ab. So, the exponential expression is the quantity 5ab, which is raised to the power of 5/4. So now I am sure that you are now prepared to tackle more exciting and challenging concepts in mathematics. At this point, prepare your notebook, your pen, and your focused mind because we will now have our assessment. I will be asking only 3 questions for this assessment. You have to be very quick in answering them. I hope you are ready, for we will now begin. Question number 1. Simplify the expression with rational exponents. A raised to the power of 2/3 multiplied to A raised to the power of 4/3. Simplify the expression with rational exponents. A raised to the power of 2/3 multiplied to A raised to the power of 4/3. You have 5 seconds to answer. Time's up. The correct answer is a squared. Question number 2. Transform the rational expression. The quantity 3b is raised to the power of 1/2. Transform the rational expression. The quantity 3b is raised to the power of 1/2. You have 5 seconds. Pens up. Your answer must be the square root of 3b. We will now proceed to our third and final question. Question number 3. Transform the radical expression into an exponential expression. The fifth root of x cubed. Transform the radical expression into an exponential expression. The fifth root of x cubed. You are given 5 seconds to answer. Time's up. The correct answer is x raised to the power of 3/5. Well, that is all for your assessment. For your assignment, answer letters in hands of your Quarter 2 Mathematics 9 Module 5. Kindly put your answers in your notebook for checking at the time set in the weekly home learning plan. That is our lesson for today. Stay tuned next week for a new lesson. Let us turn you over now to Teacher Mizba.
Thank you, Teacher Rosella. That ends our lesson for today. For you to understand our topic further, you may do the exercises provided in your modules. You may also have an advanced study of your topics to prepare yourself for your next lesson. Remember that the key to mastering mathematics is constant and diligent practice. Please make sure to be with us next session here at the School on the Air program of the Department of Education, Tagum City. This has been Teacher Miss Pajen M. Campo, your Teleradyo host. Keep safe, everyone!
TV High, dito sa City High. Makisabay, matuto't maglakbay sa TV High.